Good morning, everybody. I'm Tyler. This is Mocha Mame. Thanks for watching. I'm going to stay off camera for this one. For the next couple of videos, what I want to try to do is cut down a little bit of the noise that the Neptune 2S is making. The main noise is coming from the fans, but we do have a little bit of noise coming from the Z motor. The main issue is that the motherboard has silent stepper drivers for the X and Y axis, but it doesn't have the same silent stepper driver for the Z axis. So we have a lot of additional noise coming because of the way the stepper driver is working. It's causing vibrations while the motor is moving. We can try to put something heavy underneath. I've already tried today. I had some bricks underneath. I put some really thick vibration insulation rubber, very soft one. I put a stronger one. I put some plasticine like putty underneath, and none of this helped this specific situation for me. Depending on your table and your setup, it might help you dampen the noise a little bit, but it didn't help me in my situation. So there's one more thing that we can try to do, and that is actually change the speed of the motor. Going a little bit slower will simply reduce the noise. When we change the speed, the frequency of the sound is actually changing also. So some people might prefer a low sound, some people might prefer a higher sound, and it's a little bit about personal preference. So for me personally, I don't mind a higher sound, but I don't want to hear the low grumbling sounds coming from the motor. And this is what we're able to change fairly easily, and you can change it without sacrificing too much speed. The good thing is that the speed on the Z-axis is not so important. So the X and Y, we need to go as fast as possible with keeping our quality up. But for the Z-axis, the Z movement is so small that changing the speed only has a small effect on the final print speed most of the time. I'm going to connect by USB. After I'll show you how to do it also, and we're going to control the axis by PC. So first, let's just listen to the X axis. So the X axis is pretty silent. Now we try the Y axis. The Y axis is also silent, but the Z axis is a lot louder. But it doesn't have to be this loud if we don't mind sacrificing a little bit of speed. It could sound like this. The first thing we want to do is go online and get the firmware files. If we do a search, we can find a link fairly easily. I'll put a link in the description as well. Over here, we want to click on this file here. It gives us a quick little description of how to figure out which firmware we need to use. If we have the Neptune 2S, then we're using this version 1.3. It also has a password to open the zip file. And we go back. You can download the version 1.2 or version 1.3 depending on your printer. Go ahead and download that. If we take a look inside the RAR file, we can see there's folders for each of the Neptune printers. We have the Neptune 2S here, so open the folder. We can see it contains version 2.02. And inside this folder, we have two files. One file is the firmware, and one file is a file of the parameters that get loaded when you install the firmware. And we'll take a look at this parameter file later. Next, we're going to want to download some software to control the printer from our PC. So if we search for Pronterface, we'll find the home page. And we download this software here. Go to latest release and download your version, Mac or Windows 64, Windows 32-bit. Now inside here is just only one .exe file. So if we open this .exe file, the program will directly open for us. After this, we need one more thing. We need to get some drivers in order to communicate with the printer. So the USB cable is not the usual type of USB like when we try to transfer data. The USB cable is a type of serial communication, so sending codes back and forth between the printer and the PC. And if we're lucky, we might be able to get it to work just by plugging in the cable, but usually this is not the case. Usually we have to download and install some drivers. Now I think there's drivers on the original SD card that comes with the printer. However, I didn't actually check, so I'm going to download in case there isn't, and in case you have any trouble with that. It's always good to get drivers directly from the maker. Now, this is the maker's website. This company is making the chip on the main board, which controls the USB. This button will download a zip file. Inside the zip file, we have all these files here. What we want to do is extract to a different folder. Then from the folder, we want to open up this setup.exe. If you try to open it directly from the zip file, it's probably not going to work. We see here we have the option install, uninstall, help. Just go ahead and click install. And you'll get a message saying successful or failed. After this, hopefully, we'll be able to connect to the printer by USB, but there's also a fairly good chance that we won't be able to, and I'll show you how to get around that. Now, what we want to do is we want to connect the printer to our PC by the USB cable that came with it. Then we want to turn the printer on. Then we open up the Pronterface software, and beside the Pronterface software I have open the text file from the firmware update. Now if everything went well with no problems, we'll see up in the corner here COM something, mine is COM 5. If it's empty, then we have a problem. I've been doing many things here, but we can see up at the top I was getting this error here, permission error 13, access is denied. So I was trying to connect to the printer, but I couldn't connect to the printer. And this is because the drivers didn't install correctly. And in this case, we have to go into the device manager and manually install the driver file. So this is how we do that. So we open up the device manager and we look for ports, COM and LPT. Then inside here, we should be able to see a USB serial, and there might be a yellow triangle. We want to right click and go to update driver, then browse my computer for drivers. Here we want to go browse and we want to find the folder where we unzipped the drivers. Then we're going to click next. And on my computer, it's already installed, and uninstalling a driver takes a lot of work. Now, if it's not already installed, you'll have the option to choose the file from the folder. And what you're looking for is a ch341ser.inf. We can install this driver, and then we should be able to connect to the printer with no problem after this. At least in my case, I had to do this step, and I was able to connect with no problems afterwards. Now we're back in Pronterface, and we're going to try to connect to the printer. So on port COM 5, we have to also choose the baud rate. This is one more thing that could go wrong for us. So I'm going to connect at 9600. And we see now it's just sitting here like that. It's because I didn't choose the right baud rate. So each motherboard will be set to a certain baud rate, and depending on the setting, we need to connect at the same setting or we cannot communicate. So it's easy enough to just go one by one if you don't know, and just connect. It's not connecting. Connect. It's not connecting. Actually, the correct one for this printer is 115200. So we connect to 115200. Then what we got here got a rubbish reply from COM5. So there might have been some communication issue. If we disconnect one time, we can try it once again. And now it simply says the printer is online. So we're connected and we're able to control the printer now. So we can do a number of things. We can home the different axes and we can control, just to show you here. We can move around X, we can move the Y around. Here it shows how much we're moving, so we can do finer movements, very fine movements, 0.1 millimeter. That's 10 millimeters. We can also move the Z axis up or down. Over here we have a space down below where we can type some commands. And this is what we're going to be using to modify the firmware. And for now, that's basically all that we need to worry about. There's some other things we can do, but we're not going to get into that on this video. And the first thing that we want to do is we want to go down here and we want to run a command to see the settings on our printer. So commands are usually starting with M or starting with G. In this case, we're going to type in M503. And the M503 is going to show all the parameters that are saved into memory on our printer now. We can see here there's the steps per unit. We can see maximum feed rates. We can see the acceleration. And what we're concerned about is this maximum feed rates. So if we take a look over here at our firmware parameters, we can see the default Z max feed rate. And over here we have the same maximum feed rate for the Z axis. Now I've already modified my file. Originally this file was set at 3.0, and that's millimeters per second. So what we're going to do is, if we take a look here, we see this is a M23 command. So if we type in M203, then space Z, then a number to change to. So for example, let's go up to 3 and enter. Now we've changed in the firmware the feed rate for the Z axis. So if we try to home now, we can see that it's homing faster than it was before. And we can push the up key to get the previous command back. And then we can change this to 5, for example. And we can home again. And it's going much faster now, and it's noisier now. We can go a little bit higher. We don't want to go too high. And you get the basic idea. Now, I'm adjusting the default Z max feed rate, but I'm pushing the homing button and it's changing. What we have is also the homing feed rate. Now the homing feed rate and the maximum feed rate are related to each other. So if the maximum feed rate is set low, then we are not going to be able to home at the homing feed rate. And now my homing feed rate is set higher than my maximum feed rate. So what we see is when I adjust the maximum feed rate, it's also adjusting my homing feed rate together. It's a little bit confusing, but if you play around, you should be able to get the hang of it. So what we want to do is we want to just try out some different numbers. So originally was Z3. Now, if we change this to, for example, Z 2.5, we're going to have a noticeable difference in the frequency and the sound of the Z axis. And it can even go down as far as Z 2.55. And this is going to make a different sound also. So going within 2 decimals, what you want to do is just go down slowly, little by little, and find out which frequency sounds the best to your ears. We don't want to go down too low. If we start getting too low, we might introduce some heat-related artifacts because we're not raising the Z-axis fast enough during our prints. But if we're just dropping it down a little bit, I did a test print and I didn't notice anything bad myself. You'll have to play around a little bit. I went through all my speeds, and the speed that I really liked the most was Z 1.05. So for my ears, 1.05 was easy to listen to. It's quiet, it's a little bit higher frequency, but we don't have the same rumble and vibration. You can actually feel on the desk that there's no vibration, but at Z3, there is a physical vibration on the desk. So for me, this is a good trade-off, and that's what it is. It's a trade-off. Can you accept going a little bit slower? If you can accept going slower in return for having a quieter printer, then this is a good option for you. If you're trying to run a print farm or something, and time is money, then probably you don't care about the noise. You might even want to raise it up higher just to get that little bit of extra speed boost. This is supposed to be a tutorial of how to make things quieter, but you can also make things faster and noisier, or there's a chance that you can go a little bit faster without actually raising the noise. It's all the interpretation of the frequency. So Z3 might sound loud to you, but Z3.1 might sound quieter to you. Try going down, but also try going up a little bit and seeing which one you prefer. We don't want to go too fast for our homing, or it might cause an issue with the accuracy. Finally, what we're going to need to do is we're going to need to do a firmware update, because what I found is when we turn off the printer, what we've done in Pronterface is no longer stored in the memory, and it goes back to what we had written in our firmware file. So I like Z 1.05, and in here under default Z max feed rate, I'm going to put 1.05 millimeters per second. Then down under the feed rate, I put mine to 800. It's originally 600, but actually it doesn't matter because my max feed rate is too low. So the homing feed rate can't go that high, and it's going to home at the same speed as the maximum feed rate. In this case, it's going to be a fair amount slower, but for me, I don't really mind. Just be aware of that. If you're using a higher maximum feed rate, then you'll be able to play around with the homing feed rate as well. And just keep in mind that this is in millimeters per minute. So you'll have to do a little bit of a conversion if you're trying to use Pronterface to figure out the sound, but we can do the same thing. We can find out which sound we like in millimeters per second. Then we can convert it to millimeters per minute, and we can insert it here into our homing feed rates. And when we update the firmware, we should be able to see that in our printer. Now what we want to do is we want to take this modified text file and put it on our SD card together with the .bin file that came from the firmware update RAR file. And with these two files on the SD card, we put the SD card into the printer and we turn the printer on, and it's automatically going to update the firmware together with our new parameters. And what we'll be able to do is run homing now directly from the printer. And we can see that it's much quieter than before. It's never going to be silent, but we can get it to be a little bit quieter. If we go and try to do some manual movement, we can see that the manual movement is also quieter now. There is one more type of noise that we might have to deal with, and this is a kind of a high pitch sound coming from a stepper driver, and it happens depending on the tuning of the stepper driver. So if you have this high pitched sound that's bugging you, what we're going to have to do is open up the bottom of the printer and do some stepper driver tuning. I have the printer open now and we can see the main board. And over here are the stepper drivers underneath the heat sinks. And these are what controls the motors. And here we can see, looks like a screw beside each one. And that's a potentiometer, and it controls the voltage going to the driver, which can adjust the amount of power or torque that the motor gets. And it'll also have an effect on how hot the motor gets. So there should be a specific voltage, and we shouldn't go over it. If we start to get too high, the motor is going to get hotter. If we go too low, there's going to be not enough power, and we'll start to skip some steps or have some kind of negative effect like that. The idea is we should use the least amount of voltage necessary to get the amount of torque we need so that we don't skip steps. Now the power supply fan is really loud, but you might also be able to hear a high pitch, kind of like a wailing sound. And this is coming from my Z stepper driver. Now down here in the corner, we'll see 24 volt power supply, and it's marked on the PCB as minus and plus. So if we take the black minus lead to the minus and the red plus lead to the plus, then the multimeter should show as 24 volts. So if it shows as minus, then you've got your leads backwards, and it's important not to do that. And we're going to keep this black lead on the minus screw, and the plus lead, we can touch this potentiometer and we can get a reading of the voltage going to the stepper driver. So we got 1 volt going here, we got 1.2 volts going here, and to the Z starts making noise when I touch it. The Z got 5.8 volts. It's important to use a ceramic driver when we're doing this because we don't want to accidentally short anything. And the ceramic is non-conductive, so it's going to prevent any shorts that might happen, and we won't destroy our equipment. So if we take our ceramic driver, we can turn to the left just a little bit, a quarter turn or 1/8 turn, and we can hear the sound, the frequency changing down. So let's bring this down. As we move it around, we'll hear the frequency going up and down, and we can try to find a voltage that sounds the quietest to our own ears. So now this sounds quiet to me, but if I check the voltage, now I've got 53 millivolts, and if I push the home button, nothing happens. So I've gone down too low, and I need to try to bring it back up again and find a better voltage. After playing a little bit, what I found is that this setting here at 0.54 volts is quiet for me. Also, if I went a little bit higher to 0.63 volts, there was a quiet point. But a little bit lower is better than a little bit higher. And we need to test now just to make sure everything is okay. So do some homing and move the Z-axis up and down. And put a little bit of pressure, just a little bit of extra pressure on the Z while you try. And make sure that you don't hear any noises of it skipping steps. And if you don't hear anything, then you found yourself a good position. And that's it. Hopefully you got something useful out of this video. I have an idea to try and tackle the power supply noise next. I don't know it's going to be exactly the next video or within 1 or 2 videos. But actually the power supply is the noisiest part of the printer, and we can benefit the most from trying to make it a little bit quieter. So thank you for watching, and hope to see you again next time. If you put the black lead of your tester to where it says minus, and you put the red one to where it says plus,